Welcome everyone in this new webinar from Formlabs. Today we're going to be talking about two different 3D printing technologies, selective laser sintering and stereolithography, and we'll be covering some of the basics on what they are, what they do, and what to use them for. And we're going to help you also decide like what is the best technology for your special use case. If you want to go to the next slide, I will introduce the speakers. So I am Maïli Latouche. I am the product marketing manager for SLS here at Formlabs. And today I will be joined by Alex. Alex is an applications engineer with a Bachelor of Science in Applied Technology. He has over 5 years of experience in additive manufacturing. And today he's joining us to explain a little bit everything to you about both of those technologies. On the next slide, I will cover how the agenda is going to go. So first of all, we're going to have a short introduction. After what we'll dive in both technologies. First, stereolithography, which is our resin technology, and SLS, which works with powders. Then we'll have a deep dive on the materials. So for both technologies, what is the range of materials that we have, what properties do they have, and what kind of applications they can be used for. And then we'll have some parts on use cases and user stories.
Just giving a quick overview on what Formlabs currently offers here. So we have a pretty wide selection on the SLA front. You know, we have our desktop systems with Form 3 Plus. Our sort of benchtop larger format SLA systems with Form 3L and 3BL, and then our selective laser sintering system, the Fuse, and its complementary post-processing system, the SIFT. So really, you know, the main goal of you know, what we do here is, you know, we provide, you know, the hardware, the software, materials for everything from, you know, prototyping figurines to, you know, short run production of end use parts. Doing this for about a decade. You see some factoids down there on the bottom. You know, 100,000 printers sold. You know, 100 million prints total to date. You know, tons of materials, tons of global offices, lots of employees. So you know, we are a pretty big player in this space for sure. So just sort of jumping right into it with SLA, and just to give you you all a brief history lesson on the evolution of our SLA product lineup. So we've like I said, we've been doing this for about 10 years. It's all started in 2012 with Form 1. Form 1 was a product that was sort of started on Kickstarter, and the rocket ship sort of took off from there. And we've been sort of constantly iterating, you know, almost seems like every year, but yeah, constantly iterating on the machines. How do we make them better? How do we change it up? So and that can kind of be told here with Form 2 to the larger format 3Ls, and now with Form 3 Plus. You know, we just sort of are always working on finer tuning. You know, how can we make things better, faster, easier to use. So, skip the slide there. So for those who aren't aware, SLA stands for stereolithography, and traditionally that process is you know, before Formlabs, this was traditionally a larger format option. So traditionally, this process is done with a large vat of resin. The laser is drawing on the surface of that resin, and the parts will sort of fall into that vat. So you can imagine if you needed a 5-inch by 5-inch by 5-inch part, you would need that equivalent volume of resin to actually hold the part in there. So it made things like material changes very cumbersome and expensive. And also because it was a large format machine, the machines themselves were also very costly. So it was a pretty high barrier to entry. So the way we do it is we essentially took that process and turned it upside down and allow for a shallower vat of resin. And we actually use a laser underneath that vat. And that allows for, you know, essentially the same part quality and, you know, accuracy and things like that, but with a much shallower vat. So we're able to swap materials out. You can be much more versatile. There's a lot less waste that goes into this process, and it's something that can sit on your desk rather than in a factory space or something like that. And you can kind of see this here. So we have a traditional set of lasers and galvos and a mirror reflecting onto the bottom of our build tank, and then the build platform will sort of, you know, pull the part out of resin. So not only does it look really cool, but it is also, like I said, a much more efficient way of doing SLA versus the traditional process. So just double clicking a little bit more on what we've done to sort of fine tune this process. So, Form 1 and Form 2 were that traditional SLA process with a lot of different mirrors and galvos, which worked great. And it's how traditional SLA is done. But, we're always talking about how to make things easier to use, faster and such. So we developed a process called low force stereolithography, which uses a flexible tank and a integrated light processing unit called an LPU, which allows for a lot less calibration and, doesn't need to be as sterile of an environment. With traditional SLA, you have to make sure you clean the mirrors, make sure the galvos are calibrated. So, any miss or any speck of dust could bend the light in a certain way and create some problems. So we sort of integrated that into one unit. And the flexible tank just allows for a lower peel force, so that separation force between the bottom of the tank and the part is a low force in our situation due to that flexible tank. So it helps increase part reliability, print reliability, while still being able to use all the same resins that you've been using on Form 2s and before. So kind of giving a broad overview on some of the benefits of looking at SLA over some other printing technologies is really the high resolution and fine detail. On our machines, you can get as fine as 25 microns, which is probably like the diameter of a human hair, so super, super thin, all the way up to about 200 microns for like faster prints, but while still maintaining a lot of high fidelity. Because we're printing at such high resolution, our accuracy and print quality is also very good. You don't see a lot of like layer lines and things you would see like in FDM or some other additive processes. It's much more difficult to see the layers because they're so thin. Formlabs has a wide range of materials. I'll talk a little bit more about materials as we kind of move on. And because we've been doing this for so long, from CAD to print, the process is very seamless and is as easy to use as possible. And you're able to get a quick turnaround on parts. So you could get parts in hours, not days, compared to traditional processes, or even outsourcing to AM bureaus and things like that. Having a small little desktop machine can get you a decent amount of throughput in a day compared to having to wait for outsourcing or something like that. Applications, really SLA sort of plays in all of them, but I'll just highlight a couple here. The idea of prototyping, whether that's rapidly prototyping, kind of like what I mentioned before, with just being able to print parts faster than outsourcing or something like that. But this idea of also functional prototyping, right? So not just the look and feel, but how does something function in a real world environment? You're able to do that on our system. Rapid tooling and manufacturing aids. This is a sort of a bread and butter AM application. The idea of any kind of jig, fixtures, test fit gauges, things like that. Being able to react and create those rapid toolings rather than go through traditional means, like CNC machining or something like that. You're able to just 3D print them. Not only 3D print them, you can make them, more ergonomic. You can make them lighter, which has another whole sort of plethora of benefits outside of just being able to 3D print it. Any kind of dental application. So, surgical guides, night guards, dental models, things like that, impression molds, can all be done on our system. We have a pretty wide, customer base in the dental space for a lot of those applications. And then the idea of any kind of medical model, so being able to do like pre-surgical planning, printing out anatomy of a specific patient and being able to plan a surgery without having to sort of plan it on the fly while you're sort of in surgery, right? So being able to sort of print those models before, plan things out, which just makes the idea of, like, in this case, like a surgery would be much more smooth. They'd sort of done the planning on the before they go in. Jewelry prototyping and casting, we do have a selection of castable wax resins. So you can do anything from small jewelry to larger casting on like Form 3L. Can all be sort of achieved with our castable wax resin. So I sort of hinted on the workflow, but sort of just double clicking on it a little bit. So really with any AM process, you need to produce a 3D file, whether that's something you've downloaded off the internet or developed yourself in any sort of CAD program, and you'll export out of that CAD platform an STL file, which is sort of the bone standard file type for any additive process. You then would take that STL file, put it into our print prep software, which is called Preform, which is free to use. You can download it today. And that'll let you do everything from selecting a material, layer resolution, support structure, support densities. All of that stuff can be done in Preform, and it could be as automated or as manual as you would like. We have sort of one-click print functions where it sets all of the orientation, the support structures all up for you, or you can go in and be more precise and select, I want to orient it specifically this way. I want to put in my support structures in this specific area and not in this area. So you can be as granular or as automatic as you want. You would then print the part, pretty self-explanatory, go to the printer, press print, and then post-processing. So for SLA, because it is sort of a liquid resin that we're curing, there's going to be some residue on the part, so they'll need to be washed. We typically use isopropyl alcohol to wash off the excess resin. You then let the part dry, and you can either remove the supports at that point or cure the parts and remove the supports. It really depends on the part you're choosing and if there's any concerns about it being too difficult to remove support, something maybe after it's cured, because because we're a single material process, the supports are as strong as the rest of the model. So we've done a lot of work on like touch point design and things like that to make it as easy as possible, but some customers still will take them off before they cure. So it really depends on what you'd like to do. But wash the parts and then cure the parts in our sort of in this photo. We have sort of dedicated solutions for Form 3. We have the same for Form 3. So speaking of Form 3, just wanted to hit on some key points about Form 3 itself. So Form 3 is our desktop solution in the space. It's really sort of the main staple. So it's easy to swap materials. It has the LFS technology that I talked about, and you're able to basically print any material that we have on the SLA front with the ease of a desktop system. These machines can run, like I showed here, talking about remote printing. So you can print, upload these jobs remotely if they're on your network, but you can also run them completely offline, which is for customers that are using more sensitive IT. So like things like the Department of Defense and things like that, they're able to run completely offline as well. But Form 3 really is sort of our main staple. It's the sort of the one we've been doing for the longest, and it's on its fourth or fifth iteration, depending on how you look at it, with 3+. 3+ had a couple of changes compared to Form 3, mainly in how we stabilize the laser system, which helps with things like clears being more clear, as well as just overall print speed and like support structure improvements were brought to 3+ as well. Form 3L is the L stands for large format, right? It's about 5 times the volume of a standard Form 3, so really sets itself apart for larger parts, things like that, and in some cases multiple runs of smaller parts, just due to the larger format, but with the same sort of uptime and minimal supervision that you'd get from Form 3+ as well. So everything you like about Form 3, just bigger. And then we have the dedicated post-processing steps, right? It's a necessary step in SLA. So the parts need to be washed and cured to have sort of the the highest mechanical properties they can, and we've done a lot of work to automate that process as well. So Form Wash is an automated part washer. Sets sort of a set and forget kind of thing. Typically most of our resins will wash for about 10 minutes. Some are a little bit more, some are a little bit less. Really just depends on the resin, but generally we'll call it 10 minutes. And then Form Cure is the same thing. We have preset functions for all of our resins, our whole resin library. Pick the resin that you're currently printing with, and it runs its cure cycle. We use a mixture of heat and UV to cure parts, and that can range anywhere between 10-15 minutes up to like an hour. And again, that's really dependent on the resin that you're using. So switching gears to SLS. So SLS is a process called, stands for selective laser sintering, as you could tell. It's sort of in the family of powder bed fusion, which is sort of just generally anything that uses a powder, whether that's metal or plastics, and fuses it together by some means. So for our process and for selective laser sintering in general, this is a process in which we're using plastic powders and taking them up to temperature. So in our case, it's about 180 Celsius. So we're sort of heating up that chamber of powder and then using a laser to melt the plastic. And we sort of will go through a process of drawing that pattern, as you can see on the right. So that's the laser sort of melting the powder, having a recoater come and spread another layer of powder on top and sort of doing the same process again. This process traditionally before fuse has been sort of on the larger format. So again, it wasn't something that was super accessible to a smaller format or a smaller price point. And then fuse really helped, condense that, make it easy to use, and again, make it more accessible to the masses. You'll see on the left here, there's a little bit more of there's a little bit more going on than with the SLA systems, right? So there's a system to deliver that powder into the build area. There's heater systems that are around it to make sure that the heat in the print area stays as uniform as possible. And then sort of a similar laser system setup like SLA, but just higher powered and sort of different setup of laser, but essentially sort of the same idea of the lasers and galvos and the mirrors bending the light to draw the pattern. So it is similar to SLA in the sense that it's using those lasers, but instead of curing resin, we're melting plastic.